Hello everyone. Welcome to today's MecSoft Corporation's CAM in Education webinar. My name is Don LaCourse, a Senior Application Engineer here with MecSoft Corporation. Also with us today is Joe Anand, our MecSoft Product Manager. We're glad you could join us. The topic of CAM in education is very dear to us here at MecSoft Corporation. We partner with schools and universities around the world, and in many cases, our software introduces CAM technology to young adults for the very first time, who then have the opportunity to carry that knowledge directly into the workplace. We have a joint presentation today from Bill Bancroft Furniture Design and the Wentworth Institute of Technology. We will have a short demonstration of Rhinocam, our flagship educational product, and we'll also be reviewing additional education information and resources. Just a few housekeeping tips here. If you have questions during any time during the presentation today, use your chat window in your GoToWebinar Dialog to ask questions. We'll be reserving the last 5 minutes of the program for your questions, so go ahead and ask them. Also, a recording of this webinar is being made and will be made available in a couple of days. As I mentioned, we have two very special guests on hand with us today. The first is Mr. Bill Bancroft. Bill is the owner-operator of Bill Bancroft Furniture Design, located in Essex, Mass. Bill graduated from Brown University and obtained his master's degree in furniture design from the Rhode Island School of Design. Bill's furniture designs have been shown in galleries all across New England. Bill is also adjunct professor at the Wentworth Institute of Technology, where he teaches materials classes and a furniture design studio. Bill has been using MecSoft's CAM software, Visual Mill and Rhinocam since 2008. We also have Emma Schmidt with us today. Emma hails from Alexandria, Virginia, and is currently a junior at the Wentworth Institute of Technology, majoring in industrial design and minoring in entrepreneurial business. Emma has a passion for furniture design and hopes to one day launch her own furniture design business. While working as an intern at Bill Bancroft Furniture Design, Emma was encouraged to design, 3D model, CAM, cut, and assemble her own unique furniture design. We are pleased that Emma has allowed to showcase her design here with you today. Hi Bill. Hi Emma. Welcome to the webinar.
Hi Don.
Emma, you there?
Hi.
Hey
Yeah,
Emma.
sorry, it didn't mute me. Hi.
Okay. How you doing?
I'm doing well.
That's good.
Thanks for having us.
Hey Bill, why don't we go ahead and start with you, and you can tell us a little bit about Bill Bancroft Furniture Design and your experience with CAD and CAM software there.
Sure. So, as you mentioned before, originally from the Rhode Island School of Design, we were focused on making art furniture for exhibition, and I think as time went on, those pieces were collected by individual, patrons or collectors. But as time went on, some of my friends who were architects also started to ask me to build prototypes and get involved in architectural millwork. So for 20 years, I was working building, so it was necessary to build more than one of a kind because they were for restaurants or hair salons or things like venture capital, incubation spaces, companies like Zipcar or Orange Innovations, even Google is in Boston now. And so they require multiples of the same thing. So that's when the CAM CNC machine really became a big focus because of the necessity to make multiple and slightly varied objects for architectural millwork. So I used, a Shop Saver CNC and also Visual Mill, which was the predecessor to Rhinocam. But we use Rhinocam now, which is, I think, a much more convenient program than the original Visual Mill. So as time went on, I've been teaching at different schools. The Harvard Graduate School of Design is where I started out as an assistant and then eventually I wound up at being an adjunct at Wentworth, and so that's where I met Emma, and she was in the industrial design program, product design, and so she expressed an interest in furniture making to me. So I thought, well, maybe she would be it'd be good to have her as an intern. And so when she came as an intern, we had an opportunity to explore some interesting ideas in furniture. And so one of the periods of furniture that she didn't know quite what to make, and so I said, well, let's look at some stuff. And we came across Memphis, which is sort of a funny period of furniture design. And actually, they designed a lot of different things in the Memphis period. They did. It was from 1980 to 1988, and Ettore Satsas was an architect, and he worked with Michael Graves and about 23 other people, and they met for that 8-year period, and they met specifically to design textiles and furniture and other architectural items for the purpose of an annual exhibition. And it was very postmodern. They did metal objects and ceramics and various things like that. They used a lot of bright colors and bold geometry, and they had an exhibition every year in Milan. The furniture was oftentimes, kind of, people ridiculed it because it was, one person called it a shotgun wedding between Bauhaus and Fisher-Price. But the furniture was collected by Carl Ledgerfield and David Bowie, and it's actually having kind of a comeback because of its sort of misunderstood. And so I think Emma got a chance to see some of these designs and said, hey, I'll take a shot at that. So she was inspired to actually hand sketch some drawings, which she did in a notebook, and then she transferred those drawings into Rhino, and then eventually we started using the Rhinocam and used blanks of wood that we had actually in the shop. Call them orphans because they're nice pieces of wood that didn't get used all the way in other projects. That shows Emma's drawing. Actually, she can probably talk about it from here.
Yeah, Emma, tell us about it.
Okay, sure. So after Bill showed me the kind of Memphis design, like he said, I did some sketches in my notebook, and I kind of brought him to Bill. And this is really the first time I'd ever even taken a crack at designing furniture. So I kind of asked him if any of these designs were possible. And I said that this one was sort of my favorite one. And we kind of had a chat about how that was not really conceivable because we didn't think it would stand up the way I had originally designed it. But we made it work, and we tested it out, and we still weren't sure that it was going to work until we finally built it. And it's actually pretty sturdy. So that was a fun thing to find out. So as far as working with Rhinocam, this was my first experience with it in the spring when I was working with Bill. Through our school's program, they teach us both Rhino and SolidWorks, but it wasn't until this summer they actually did anything with CAM software. And so in the spring I was working with Bill and we did Rhinocam, and then this past summer with my school we did CamWorks, which is through SolidWorks as opposed to Rhino. But I really enjoyed working with Rhinocam. I thought it was really cool how we could see all the toolpaths and stuff, which I think you can see in the next couple slides. But yeah, I just thought it was really fun. So here you see the a table that's about 9 inches wide because it goes in my entryway hallway in my tiny Boston apartment. So there's not much space there to begin with, so I made something really skinny and that wouldn't be obnoxious for my roommates so they wouldn't bump into it. It's slightly angled just to give it something fun, and yeah, we just have the cool patterns in the wheel, and I think that's good. So as I was talking about in the wheel of the table, so the wheel doesn't actually do anything other than look pretty, but we created it in the Rhino program, and then we tooled it so that it could be CNC'd, and it's actually cut not in half, but kind of awkwardly onto the side there so that we could attach it to both sides of the table, since that's much easier than actually going through the table with a whole wheel.
Yeah.
Yeah, the table design is actually ready to assemble, so she can take it apart and move it from home to home as she moves. So that was part of the idea.
What are we looking at here, Bill?
This one, those are the slides for the stretchers, and also the little angle brackets that we use to help glue up the flat surfaces of the design. So we were going to attempt to build the stretcher, or the curvy, kind of the serpentine part, out of solid wood, but it wasn't possible because of the short grain issues. So we decided to build it out of multi-layer plywood. I think we used Baltic birch, and so we had to nest the patterns on a 4x8 sheet of plywood to get a thick enough stack to laminate them together to create the stretcher. And so those L-shaped pieces are, again, just the pieces that we use to ensure the right angle during the glue up. So I think Emma nested them together so that they could fit on the 4x8 sheet of plywood. And because it was going to be painted, grain wasn't really an issue.
Yeah, I noticed also you see in the bottom right corner part of the dialog for the 2.5 axis profiling dialog. This is the advanced parameters dialog. You see the bridges and tabs section, and what this does is it puts bridge areas between your part and your stock automatically to help keep the stock fixed on the table. And you can see some of the tabs right here, the triangular tabs here. You can see them. You can see them over here on the toolpath as well.
Yeah, that's a very useful feature. We use that all the time. It's less time consuming than leaving an onion scan, or and also with a new Rhinocam you can change the shape, so it could be a triangular shaped one or a rectangular shaped one depending on the material.
Now this is interesting. Tell us about this.
Well, Emma, do you want to talk about that?
Oh yeah, sure. So we kind of, along with the wheel too, we wanted to see how much we could do with the Rhinocam and the CNC. It was kind of all an experiment, to be honest, including whether, like I mentioned before, whether or not the table would even stand up. So the finger joints are actually, we wanted to see if we could make really nice finger joints using the CNC, since they have to be perfect anyway, for them to fit together nicely, and we made them graduated. So if you can look in the central middle picture, the finger joints on the right, you can easily see that they get bigger and then smaller in the middle and then bigger again. And we also, since the table was angled, we had to make sure they were cut angled and arrange them on the table so that the tools could get in without overstepping anything. So that was a fun little thing to work out. We had to test that out before we went into the walnut to make sure we didn't waste anything.
One thing to note too on that, because it was angled, you couldn't use 2-axis toolpaths with that. You had to use a 3-axis finishing toolpath. And I noticed that's a horizontal finishing because of your angles. You got a 2-degree angle on there. It turned out pretty good.
Yeah.
That's right. You can't actually get an undercut with a CNC. So the left piece of that is actually cut down, and then the second piece is rotated or flipped so that it's also can actually machine all the pieces. So that's how that was arranged.
Yeah. And it came out really nice, I would say. Like, we had to do very little cleanup to make them perfectly fit together. So.
So it fit together good when you assembled it?
Yeah, absolutely. And you can see in the final picture that it looks pretty.
Yeah, it looks pretty nice. Pretty cool. Okay.
Yeah, I think we were able to. Go ahead.
Oh, no, go ahead. Sorry, I didn't mean to interrupt you.
I was just saying that we were able to adjust the tolerances. I think we changed the tolerances a couple of thousandths of an inch between the first prototype, the first test piece, to the final cutting of the walnut. So they were actually too tight when we first cut them, and then we changed the tolerances maybe 1 or I think 3/1000ths of an inch to create a little bit of a looser connection, and the fit was excellent.
Cool. That's great. Bill, Emma, if you could stick with us till the end of the program. We have a Q&A session coming up.
Absolutely.
Thanks, guys.
Sure. Yeah. Okay.
Next up, we're going to have a short Rhinocam demonstration. We're actually going to show you how to cut the wheel in Emma's design. So let's go ahead and bring Rhinocam up and we'll show you how to do that. So here, I hope everyone can see my screen. This is Emma's design of her table in 3D in Rhino. And we have some dimensions thrown in there. It gives you an idea of the various components in her design. What we're going to machine actually is the wheel down here. And let me go to another screen and I'll show you how to machine, how to program that. I hope everybody can see that. What we got is Emma's wheel component in Rhino. And just a little bit about Rhinocam. Rhinocam is a completely integrated plugin for Rhino 5.0. So once you install Rhinocam, just drop down the Rhinocam menu up here and select the module you want to run. And we have the milling browser over here on the left. And all of your commands needed to program your toolpaths are all located right here on this browser. So it's real easy to program a part. You just start with the Program tab and work your way from left to right. Also down here you see that we have a couple of tools already created that Emma used for this design. So we'll go ahead and review the components we have already defined. We have a machine set to 3-axis. We have the post set to Bill Shop Saver Win CNC post. And we have a box stock. Let's turn our stock on so you can see the box stock there. And we also have a setup one, which is defined automatically for you when you open a file. So let's go ahead and create some toolpaths to machine this part. We'll turn the stock off for a moment. Now, to machine the decorative pockets on the top, Emma chose to use a 3-axis horizontal finishing operation, which interprets the 3D model underneath and can be contained by 2D geometry as well. Let's go ahead and do that. So we'll pick 3-axis horizontal finishing, and to contain the toolpath we have just a plain 2-dimensional circle on the top of our drawing that we're going to select for a containment area. So everything inside this circle on the part is going to be machined. So we're going to go ahead and select our tool. We're going to use the flat mill 1/4 inch that's defined in this part. And for the speeds, we'll leave those set to the default values from the tool. The clearance plane, this is the plane that the tool will retract to, as well as transfer motions will be performed on. So for the cut parameters on horizontal finishing, you can set the tolerance obviously and the stock, how much stock material you want to leave on the part after machining. We're going to leave that set to 0. And for cut direction, we're going to use climb conventional, which is a mixed cut direction. And for the cut levels, we're going to go ahead and set a step down of 5%. So each of these pockets is going to be cut in horizontal planar sections through the part at a 5-degree step down of the tool diameter. So for the cut levels ordering, we're going to do depth first. So each of these pockets will be machined. One pocket will be machined, then the next one, and then the next one. Now also, we have the bottom containment set to minus 0.75. So everything below down to minus 0.75 and within this circle is going to be machined, which means basically all the pockets will be machined without having to select. And let's go ahead and generate this. So here you see, let's take a closer look at this. You see that there's a 5% step down of the tool diameter. So there's a horizontal plane slices through the part at each step down level, and the toolpath is generated from that for each pocket. Okay, now that we got the pockets machined, let's go ahead and do we have a pocketing operation that will divide this wheel into 2 parts. that the design requires. So all we need for that is a two-dimensional rectangle just to contain the area of the pocket. So let's go ahead and do 2-axis. We'll do pocketing. For the region, let's remove that and select our rectangle. And for the tool, we'll use the 3/8 inch flat end mill. Beads and speeds, we'll leave those set. Clearance plane the same. And for the cut parameters, we'll have a tolerance of 1/1000, 0 stock, meaning it's going to cut right up to this rectangular containment area. And we're going to use an offset cut pattern, a mixed cut direction. We're going to start on the inside of the pocket, and we'll have a step over of 25%. So this is in the X and the Y step over. And let's go ahead and do a cleanup pass on this. So it'll clean up the sidewalls as it does each level. So for the cut levels, this is our cutting depth for pocketing. So for the location of cut geometry, where is our cut in relation to our 2D geometry? It's at the top of our cut, and we're going to cut a total depth of 1.5 inches. And we're going to have each roughing depth is going to be 0.15 deep. And we're going to do depth first. Obviously, there's only one pocket. So let's go ahead and generate that. So here is our pocketing toolpath. You can see here within the rectangular area, and we're going to simulate this in a second, show you what that looks like simulated. So now what we have to do is the outer perimeter of the wheel. We're going to use 2.5 axis profiling for that, and we'll select profiling. Let's remove that, and for the containment area, we're just going to select the outer perimeter of the wheel. So for a tool, we'll use the 3/8 inch flat end mill again, and for the cut parameters, we'll use a tolerance of 1/1000. Stock will be 0, so we're going to cut right up to the sidewall for a finishing cut on the wheel. We're going to use a climb cut direction, and what we're going to do is we're going to check this box for use inside outside for closed curves. This is a closed circle, obviously, so we're going to cut on the outside of the circle. And if you wanted to do a cutting width, for instance, if you wanted to start outside this diameter and work your way in successive profiles, you could do that. We're going to leave this set to 0, so we're going to have one profile pass at different depths. So for the cut levels, where's our geometry? It's at the top. Again, we're going to have a total cut depth of 1.5, and here we'll have a rough depth per cut of 0.2. And also you can set your entry and exit for pocketing. Currently it's set to none, but you could also do a ramp entry motion, or you can do a linear or radial entry and exit motion. So let's go ahead and generate this. So here's our profiling operation. Let's go ahead and simulate these. Do them one at a time here. So there's our 3-axis horizontal finishing. And let's go to the pocketing. And you can turn the toolpath on and off if you want to see it. So there's our 3-axis horizontal finishing and pocketing. Let's go ahead and do our profiling. So there we go. We got the wheel machined, and let's go ahead and if you want to post this, you can post these out one operation at a time, or multiple operations, or the entire setup. Let's go ahead and do the entire setup. Post that out. And here is the G-code for the Shop Sabre Win CNC controller on Bill's 3-axis mill. Now, also, our product runs not just in Rhinocam, but you can also run it in our standalone program, Visual CAD-CAM. You can run it in SolidWorks, and you can run it now you can run it in a Libre design. So let's go ahead and show you those real quick. So there's Visual CAD CAM, and also let's go ahead and show you SolidWorks and also a Libre design. So you can run them in Rhino 5.0 or standalone Visual CAD CAM, SolidWorks, and now also a Libre CAM. Now, also as a special treat, I happen to have a video of this wheel being machined that Bill was kind enough to provide. So let's go ahead and show you that as well. I hope everyone can see that. Let's go ahead and run this. It's not very long, so let's go ahead and take a look. So that is the 3-axis horizontal finishing operation on the pocket areas. There we go. And next up, we're going to give you some additional information and resources about our educational products. And Joe Anand, our product manager, will be assisting with this. Joe, you there?
Yeah, I'm here, Don. Thank you. So do you just want to go to the website,
Yeah.
bring up the website?
There we go.
Hi, everyone. So what I'm going to be talking about is just show you what we have in terms of products offerings for the educational market, and some of the resources that we have available for you as educators to take advantage of. So if you go to our website, which is MecSoft.com, which is what Don is showing here, and Don, if you go to the industries section in the menu bar, and then pick education. Education is the last one there. If you select that, and this is our education portal. This is where you can find all the information about our products, the solutions, the various solutions we offer, the pricing on our products, and also customers who are currently using it. So let's go through each one of those. If you pick solutions there, Don. So what do we offer in terms of educational products? We have basically two sets of products that we offer. One are lab licenses. This is and then the other one is Campus Cam. I'll talk about the lab licenses first. So basically, lab licenses, you can buy the products starting at five licenses in a lab, and then you can add on in increments of 5, and you can go up to 100 licenses per installation. The access is restricted to one lab or a classroom network, and this is one of our most popular configurations that we sell. And the reason is most people would like to put the product on one lab and run it from there. But there are some schools that want additional access to the products, and then we have the Campus Cam option in that case. Here, what you can do is you have unlimited licenses across the network, the school network anywhere. I mean, as long as you're in the school network and you're logged into the network, you can access the Campus Cam license, and you can run it on a laptop. You can be sitting in a library somewhere, and you could run the CAM license. So this is for schools that need a lot of licenses. So if you're implementing CAM across maybe an entire department, this would be an appropriate license to buy. So let's talk about pricing next. So we offer the lab license, as I said, is the most popular one. It's also the cheapest options. We offer 2 different configurations. One is the professional configuration, which you get the entire Mill Professional module, and that starts at $1,250. And if you're in the Eurozone, it's €1,250. And then the Campus Cam option, it starts at $3,000. That's the Campus Cam. Again, we have 2 different configurations. One, you either get the professional configuration or the premium configuration. The premium configuration allows you to run continuous 5-axis toolpaths. Most schools don't have 5-axis machines, so we typically sell the professional configuration, which is restricted to 3 and 4 axis. Another place you can get the pricing is actually if you go to our e-store button up on the right-hand side and the top there, Don. To click on the e-store. So this is our e-store. Most schools I know will not buy through an e-store. They usually will typically issue a PO and would require an invoice. So if you select the education entry on the left-hand side there, Don. But you can get an idea of the pricing of our different products here. So if you look at, as Don mentioned, our educational products run standalone inside Rhino, as well as inside SolidWorks and a Libre design. So depending on your CAD needs, what CAD you're using in your lab or in your campus, we have plugins that run on the CAD system. And so if you click on the visual mill there, select options button there, Don. So if you want to get an idea of pricing, this is the best way to get the idea. So if you go up there to the user level and you select the number of licenses that you want. So if you want to start with 5 user, go ahead and select that, Don. And you see the price shows up at $17.50. What you see here is actually the AMS, or the annual maintenance subscription, added to it. And the annual maintenance subscription basically gets you the upgrade, the free upgrade to the next level, next version of the product release, as well as our Cam Jam video set, which is about, if I'm correct, Don, is about 100 videos that we have.
Between 85
videos.
to 100, yes.
It's
It's 10 hours
and you
of
get
training.
it's 10 hours of interactive videos that our support people have put together to help you get up and running with our products. So that's a little bit about the pricing, and you can always call us if you're interested to learn more about the pricing. So if you want to go back to that other tab, Don, to our main website, the first tab. And as far as resources that we have for you to get started, we have quite a few resources. Actually, we do have projects that we have done with the G-code that you can immediately get access to, and that's actually public domain, so you don't need to even be a customer. So if you go to the resources tab there, section there, there are videos you can access, and then there's even the F1 car, which is a very popular one. There's a project that we give to high schools for creating the F1 car. We actually provide both the design for the F1 as well as the toolpaths and how to machine that. So there's quite a few resources here that you can access, and then you can always talk to us about anything specific in terms of curriculum development or anything like that. You can talk to us directly, and we'll be more than happy to help you out there. Finally, I want to talk a little bit about our customers. If you go back to the customers, so here we list some of the customers we have. We're quite proud that our system has been adopted by in a variety of schools, not just schools that are well known in terms of name recognition, Ivy League schools in the U.S., even smaller schools, the regional schools, trade schools, high schools. So we're pretty proud of the fact that we have quite a big representation on the educational market with our products. One of the reasons is because it's pretty easy to use, and the students are able to get their hands around our product pretty quickly. And if you also, we have quite a few institutions overseas that are running our product. You can take a look at these. This is just a listing of some of the more well-known schools that we have. The case studies, you can also learn about how our customers are using our product, and quite some interesting work. We've chosen some interesting pieces that they've worked on and showcased them here. And these are some things that you can implement in your own school as well. That's pretty much all I have, Don. So you're more than welcome to talk to us. We're available on our website as well as our phone call. You can call us and talk to us about our needs, and we'll be more than happy to help you. Thanks, Don.
Thanks, Joe. Okay, next up is our question and answer session. If you have any questions about anything you've seen in the webinar today, go ahead and type them into your chat window and go into your GoToWebinar dialog, and we'll get to them. Joe, do we have any questions throughout the program? Looks like we lost Joe. Let's see if we got any questions come in here.
Yeah, actually, sorry, I was had my mute button on. So yeah, there's only one question there, Don, about the Torchmate not talking to Rhinocam. Yeah, we will take a look at that and talk to people in Torchmate to make sure that they have the right interface
Okay.
to Rhinocam.
I had a question for Joe, for Bill. If you don't mind, I wanted to go back on one of these earlier slides. I wanted to see, Bill, if you could, we didn't get a whole lot of information about some of the images that are on that first slide, and I wanted to see if you could tell us a little bit about each of these projects. They look pretty cool. Bill, you there?
Yes, I am. Yeah.
You should see it now.
Oh, there we are. Sure. Yep. Well, actually, there's a couple different things on this page. The top left is a kind of a lobby for a condominium complex near the Mass General Hospital in Boston, and so the designers wanted to have a lively place for the residents to gather, and so we were contracted to build, I think, several pieces of accent furniture, and so the idea would be that these things would be installed and then just kind of stay there forever. Mm-hmm. And so they had a gymnasium and several meeting rooms, a corporate meeting room, kind of a dining area, and also more of a lounge or a hotel sitting area. And I think this is an image of the hotel sitting area. You can see it has a fireplace. And so we designed these pieces to to go in there. They're extremely heavy and solid, so that they wouldn't tip over or be easy to move. And then down underneath that, you can see images for a kitchen, and that's a residential project. And I think that one piece that has a glass top shows a very old European chunk of wood, which is actually a cutting board that was extremely worn from 100 years of chopping. And so the surface was not flat in any way. So we actually did use the CNC to drill holes in the top of that old chunk of wood down to a certain depth, so that it would support that glass. There are little aluminum rods of all the same length that go into those holes, and they support that piece of glass evenly. So that was actually done on the CNC. As well as the entire kitchen. The entire kitchen was built with the CNC, with the Rhinocam. So we do that type of thing all the time. This other image over to the right is just a concept image. So it was never built. It's a stand for a piece of art. Actually, that's the image of a graffiti artist's kind of a comic book box, and the patron wanted to have a stand for the pedestal for that piece of art. So we made the Z-shaped pedestal, but it was never actually built. It was just rendered in Rhino. And that other image there is also a bench which was built out of a solid slab of cherry. It was all machined on the CNC, and then it was cut and folded and mitered so that it would turn into a bench you could sit on. And many of these benches were built for a large rowing facility on the Charles River in Boston, and for the rowers to sit on when they were having meetings. And so the surface was there were a couple of different versions. Steve Listwan, who was one of my co-workers at the time, designed this particular piece, and he wanted to have a kind of a fishbone pattern. So he put a very bold fishbone pattern on the top of the cherry, and we did all of the Rhinocam similar to Emma's wheel to machine out all of those negative areas in the surface. So it has a kind of a bold surface pattern, and it's kind of fun because I think this piece in particular challenges people's perception of of what a seat can be, because normally they look at it and they say, oh, it has these bumps on it. I can't possibly sit on that bench. But then if you imagine people sitting on a stone wall, if they're having lunch outside of an office building, they go through the same process when they look at a stone wall and they go, oh, I wonder if I can sit there. And they make a decision about where they're going to sit, and then they sit on it and eat their lunch. So it's kind of the same idea, just trying to get the user's attention for 1 second.
Now that one at the top right is interesting with the hands and the feet. What's going on there?
Oh yeah, the one at the top right with the hands and the feet. That's for the Minilux Minilux nail and toe salons, mostly here in Boston. And some folks from the Harvard Business School got together and wanted to start a concept for nail salons that were, a sort of cut above what you could normally find in most American cities. And so they wanted to have a higher level of hygiene and better products available for purchase, and a much more austere and upscaled venue to get your nails and your manicures and pedicures. And so these panels were images of hands and feet, and the panels were perforated with thousands of holes for each panel. And there's acoustic baffling behind those panels, as well as some LED lighting, which can be lit up for accent lighting.
So what kind of operations did you use for the holes?
Those were mostly pec drill, I believe is what it's called, or incremental drilling.
Right.
And so, with a panel that has several thousand holes, we were able to adjust the CAM software so that we could really optimize or minimize the amount of time it took to run each panel, because each panel would take over 2 hours. And
so was that just using a drill bit or what?
We used a special drill bit called a through boring bit, and it is a specialty bit that has a very high angle, and the actual carbide cutter has got an up shear, so that when it cuts through the top surface of the plywood, it does a nice clean job. But more importantly, as it's cutting through the bottom surface of the plywood, it pulls the material up into the hole so that you get a really clean exit hole. And that's kind of a complicated thing to do on a piece of plywood, but we were able to adjust it so we could do, we did an awful lot of panels for these places. And so, thousands and thousands of holes.
Great, Bill. I appreciate that. Let's go ahead and go on to our last slide, since we're about wrapped it up. Let's go ahead and get to that so that people know where to call us to get some information. I hope everyone can see that. And if anyone has any questions or information or requests for information about anything you've seen today, just give us a call and we'll be glad to give that information to you. Well, that concludes our webinar for today. I want to personally thank Bill Bancroft and Emma Schmidt for taking time out of their busy schedules to speak with us today. Thanks, Bill. Thanks, Emma. We really appreciate it. It was very interesting.
Don, before we close, there was one question for Bill. For Bill, what was the name of that boring bit? Bill?
The boring bit was it's called I think if you do a Google search on the internet and you call it a through hole boring bit, you'll see images of several different types. They're typically used for for drilling into plywood, and they have they're steel typically or solid carbide, but it's called a through hole boring bit. And if you do a search, you'll see it. And they have a kind of a robust shank, and then they have a upward spiraled body, and then a very sharp point, which is more than the typical jobber drill. So you have a much, jobber drill's got I think a 45-degree angle or 40-degree angle. These are much closer to 60 or 70 degrees.
Oh, okay. Okay, well, any more questions, Joe?
No, I think that's it, Don.
Okay, thank you. Again, I wanted to thank Bill and Emma for being with us today. I think it was very interesting, and I think our attendees enjoyed it as well. I also want to thank all of you, our attendees, for joining us. We're very glad you could attend. We hope you walk away with some helpful information about MecSoft's CAM products for education. Again, if you have any questions about our presentation today or want any additional information about any MecSoft product, please give us a call. You can Skype us, you can chat with us online, or you can visit us at mecsoft.com. Thank you, everyone, and have a great day.
Okay, thank you, Don. Yeah.
Okay.